Okay, we're going to go over measuring infiltration. The first thing you need to do is have all the materials that you need to go ahead and measure your infiltration, and also have scouted out the field ahead of time. The first thing that I like to do is find different parts of the field that maybe have been managed differently. In this case, we're setting up our infiltration measurement on an area that has is close to a field row or end rows, so you would expect there's going to be some compaction that's going to slow infiltration. And what you can do is take like a wire flag in this example, and you see how hard it is to go in. So this would ideally be a place where we would show low infiltration with the managed, how this part of the field is managed. And then I would move to another part of the field where this wire flag would maybe easily go in, so I could do a compare and contrast. So typically we want to set up two infiltration experiments at the same time so we can compare the numbers and run them roughly at the same time so the conditions are the same. So the materials needed are our 3-inch infiltration rings, diameter rings, and you would ideally again have two of these. If you don't have the mark on the ring, there's a 3-inch mark. We want to go ahead and drive it down to that 3-inch mark. If you have a ring without the groove here, you can go ahead and measure that with a tape measure and mark it with a permanent marker, both inside and out. And then you want a beveled edge on the bottom so it will drive in easier. We're going to want to have some plastic wrap. In this case, I just have saran wrap. Also, you can use flour wrap. It may not stick quite as bad, might be better, that you would get at a florist shop. You're going to want to have a plastic bottle that has the 100, in this case it's 107 milliliters that's needed for 1 inch of water for this 3-inch diameter ring. If you have a different size ring, you would need to determine that. So we have that simply marked here. Also, ideally you would use distilled or rainwater because that's will make a difference on infiltration if it has some salinity, so you want to use distilled water. And then a stopwatch or a timer, and I just use my cell phone to do that. Okay, the steps we're going to go through to prepare the infiltration tests are on page 4 of your Infiltration Educator's Guide. Now, the first thing we want to do is, when we set up our ring, clear the residue off. So in this case, I've already driven it, but ideally you might have a scissors if you have a lot of residue. So it's cleared off if there's any rocks or those types of things, so we're set there. The next thing we're going to do is go ahead and either use a driving cap, and you have a weight. If you have soil, that works pretty easily. You can use this Walmart weight. In this case, this is a compacted area of the field, so I had to use basically a wood block and a little sledgehammer, and then I go ahead and drive it. When we're done driving it, we're going to drive it down to this 3-inch ring like that, and then make sure that we've got the correct depth, because we can also use this same ring for our bulk density sample later if we want. And so we're going to should be right at 2 inches all the way around. It's a 5-inch depth ring, so the 3-inch ring will be right at ground level. So now we're ready to go ahead and do our infiltration test, and we simply take the saran wrap, make sure that we get it down to the surface. It's fairly flat and it's around the edge so I don't lose any of that water. And what we're doing here is we don't want to just pour the water in. We want to release it all at one time. That's the reason for the saran wrap. So I'm going to take my vial, take my distilled or rainwater. I'm going to fill it up to that 1-inch mark. That right at the 1-inch mark. Okay, and I can go ahead and dump the water in. Okay, then we just simply pull the plastic back, ready to release, and then right when I release it, I start my timer. And it works best usually just to use in this case I'm using a cell phone. And then what we would do is either simultaneously we could go to another site that we could use to compare. In the book I have a row traffic, or an area where row traffic was, and I have an area of the field that's better managed. In most cases we're going to do 1 inch of water if the ground has already had recent rainfall or recent irrigation and it's near field capacity. We probably don't need to do the 2nd inch of water. In this case, we're just going to do 1 inch of water because we had a rain last night. And what we want to do is monitor this, and once the water is all the way gone to where it's just glistening on the surface, that's when I would stop my timing and record the number of minutes. When we record the minutes, it's probably easiest to use a little field notebook to measure it and write the information down. You should record it to the nearest 10th of a minute. For example, if it was 1.2 minutes, or if it was 1 minute exact, that type of thing. So if it's 1.5 minutes, and then that way we'll be able to determine the inches per hour is a normal term. You can see how we're getting a little bit closer. We got water that's still on the surface, so we want to wait till that's to the point where it's just glistening on the surface, and then I would stop my timing. We're getting to the point now where the water is just glistening on the surface, so I'm going to press stop. And right now when I press stop on my stopwatch, I'm at 3 minutes and about 40 seconds. So that's about 3 minutes and 2/3, so 3.6, 3.7 minutes. I would record that. And then from there, I would go ahead and determine the infiltration rate per hour. So in this case, we took in 1 inch of water in 3.7 minutes. So I would go ahead and do my calculations as shown on the educator's guide. And then I would compare that to another part of the field. If this was not fairly wet, we would go ahead and do a 2nd inch to see if we can get to steady state and go through the same process and then determine whether or not we're getting close to steady state on our infiltration rates.